Hello students, today we will discuss about D'Alembert ratio test. D'Alembert ratio test, in short you can say ratio test. If summation un is a series of positive terms such that limit n tends to infinity un upon un plus 1 equal to L. Convergent or divergent it will depend on L. First case, if L greater than 1 then summation un is convergent. If L limit value of this is less than 1, summation un is divergent. If L equal to 1 then test will be failed. We will apply another test. Now question based on this test. Test for convergence the series 1 upon 2 plus 1 upon 2 into 2 square plus 1 upon 3 into 2 cube plus 1 upon 4 into 2 raised to the power 4 plus dot dot and so on. Now this series can be written as 1 upon 1 into 2 because other terms are product of 2, that's why 2 can be written 1 into 2 plus 1 upon 2 into 2 square as it is plus 1 upon 3 into 2 cube plus 1 upon 4 into 2 raised to the power 4 and so on. Now un that will be 1 upon nth term of 1, 2, 3. First term 1, 2, 3, 4. Nth term of 1, 2, 3, 4. Now we will take another second term that is 2 square, 2 cube, 2 raised to the power 4. Now nth term of 1, 2, 3, 4 it will be AP and you know the nth term in AP that is A plus n minus 1 into D where A is first term. Here that is 1, 2, 3, 4 dot dot, so A first term will be 1 plus n minus 1 into D that is common difference. Second term minus first term 2 minus 1 that will be 1. So it can be written 1 plus n minus 1. 1 to 1 cancel n. So nth term of 1, 2, 3, 4 that will be n. Now for second term that is base. Base is 2 and power value of powers that is 1, 2, 3. Again 1, 2, 3 that will be your AP and nth term in AP that is n. So it can be written 2 raised to the power n. Base is same 2, 2, 2. Power change 1, 2, 3. That's why it will be 2 raised to the power n. Un is 1 upon n into 2 raised to the power n. Now un plus 1. N will be replaced by n plus 1. So 1 upon n plus 1 into 2 raised to the power n plus 1. Now according to ratio test, limit n tends to infinity un upon un plus 1. Limit n tends to infinity un that will be 1 upon n into 2 raised to the power n into un plus 1 1 upon n plus 1 into 2 raised to the power n plus 1. That's why it can be simplified. Limit n tends to infinity n plus 1 upon n into 2 raised to the power n plus 1. It can be written 2 raised to the power into 2 because you know a raised to the power m plus n equal to a raised to the power m into a raised to the power n. That's why 2 raised to the power n plus 1 it can be written 2 raised to the power n into 2. Now 2 raised to the power n to 2 raised to the power n will be cancelled out. Now 2 is numerical value. It can be written before the limit. 2 into limit n tends to infinity. Now n plus 1 upon n. You can write it such way n upon n plus 1 upon n. N to n will be cancelled out. That's why 1 plus 1 upon n. Now put the value of n. 2 as it is 1 plus 1 upon infinitive. N will be replaced by infinitive. So you know 1 upon infinitive that will be 0. 2 into 1 plus 0. 1 plus 0 that will be 1. So 2 into 1 2. 2 is greater than 1. 2 is greater than 1. Now by ratio test it will be L greater than 1. So series is convergent. So by ratio test the given series converge. Now another question. Test for convergence the series 1 square into 2 square upon 1 factorial plus 2 square into 3 square upon 2 factorial plus 3 square into 4 square upon 3 factorial plus dot dot. Un that will be the nth term of 1 square, 2 square, 3 square. You will take first term 1 square, 2 square, 3 square and so on. Second term that is the nth term of 2 square, 3 square, 4 square dot dot upon 1 factorial, 2 factorial, 3 factorial. That is the nth term of 1 factorial, 2 factorial, 3 factorial. That will be n factorial. So un can be written n square into n plus 1 whole square upon n factorial un plus 1. This time n will be replaced by n plus 1. So it is n plus 1 whole square into n plus 2. This n will be changed by n plus 1, or 1 is given. So n plus 1 that will be n plus 2 square upon n that will be replaced by n plus 1 factorial. So limit n tends to infinity un upon un plus 1. Limit n tends to infinity, put the value of un. Un is n square into n plus 1 whole square upon n factorial into un plus 1, that is n plus 1 whole square into n plus 2 whole square upon n plus 1 factorial, that will be numerator. This time n plus 1 whole square to n plus 1 whole square, that will be cancelled out. Now limit n tends to infinity, n square upon n plus 2 whole square into n plus 1 factorial. N plus 1 factorial can be written, n plus 1 factorial, it can be written n plus 1 into n factorial. You know, if you have 5 factorial, it can be written 5 into 4 factorial. That's why n plus 1 factorial can be written n plus 1 into n factorial. So n plus 1 into n factorial. This time n factorial to n factorial will be cancelled out. N square as it is into n plus 1 upon n plus 2 whole square. N plus 2 whole square, you will take n common, power is 2, that's why it will be n square. N square, and in bracket 1 plus 2 upon n whole square. Now n square to n square will be cancelled out. Now put the limit. Limit n tends to infinity, 1 upon 1 plus 2n whole square into limit of this. Two terms are there in numerator or denominator. Limit can be taken separately. That's why limit of this function into limit n tends to infinity n plus 1. Put the value of n, that is 1 upon 1 plus 2 upon infinity. 2 upon infinity, that will be 0. 1 plus 0 whole square into n replaced by infinity, infinity plus 1. So 1 plus 0, 1 square, that will be 1. 1 upon 1, 1 into infinity plus 1, that will be infinity. 1 into infinity, infinity. And infinity is greater than 1. Again, limit greater than 1. So by ratio test, summation un is convergent. By ratio test, the given series converges. Thank you.